Hello, everyone, and welcome to Algebra 2, Section 4.6, the Fundamental Theorem of Algebra. Today, we're going to be studying more about the zeros of a function, which, when they're real, are the same thing as the x-intercepts of a function. But let's start with a little bit of review here. The directions say to match each function with its graph using the y-intercept. Remember that a y-intercept is where a function crosses the y-axis. And every single time a function crosses the y-axis, no matter where that happens, the x-coordinate is 0. So to find this y-intercept using the function, we can let x be 0. Well, if this is 0 and this is 0 times 3 will still be 0 and this is 0, then we're just going to get 5. When x is 0, remember this is y is going to be 5. So let's look at our bunch of graphs here and see if any of them have a y-intercept of 5. This y-intercept is 0, -3. This y-intercept, 1, 2, 3, 4, 0, 4. This one is 0, 0. This one looks good. 1, 2, 3, 4. Yep. This one is 0, 5. So our graph is D, but let's just finish these up while we're here. This one's 0, 2. And this one is 1, 2, 3, 4, 5. Looks like 6. 0, 6. So I know now that I'm looking at graph D. But then the second step says, then state all of the zeros of the function. Now remember, there's two kinds of zeros. There's real zeros, which are the same as x-intercepts. X-intercepts and real zeros are the same thing. And then there's also a possibility of imaginary zeros. And imaginary zeros are created when a function doesn't actually come back down and hit the x-axis. So this function would have two real zeros, but then two imaginary ones. They're not necessarily right there, they're imaginary. But meaning if this had come down and actually hit the graph, it would have had two more. So that's how I know it has two imaginary zeros. So let's look back at the graph that we chose. So we chose D, and I can see that it has one real zero. And that real zero is at -1, 0. Remember, a 0 is when the y-coordinate is 0. Just like the y-intercept is when x is 0, the x-intercept is when y is 0. So what's awesome is that even though I could only find one, I can use that one in synthetic to find the rest of them. So remember that synthetic means that we put our values, our coefficients right here. If there was a missing spot, we'd have to put a 0 there to hold the place. And then I'm going to add, multiply, add, multiply, add, multiply, add. And I expected that to come out to be 0. Remember that you put the x in this side and the y pops out the other. This is always an ordered pair. So if x is equal to -1, y is 0, which we knew to be true from our graph. But now we can use these to do a couple things. We can factor this. Now I know that x plus 1 is a factor. And then the other factor is x squared minus 4x plus 5. Synthetic is very cool in my opinion. Now normally you'd want to factor again. And sometimes people, I've been pushing for factoring pretty hard. So sometimes people work pretty hard to factor and they say x minus 5 and x plus 1 because they see that that'll make a -4x in the middle. But don't forget when you're doing your signs to always check the last times the last. And unfortunately, that does make a -5. So as much as I love to factor, this one's not factorable. But the other way you could have known that is because the other zeros have to be imaginary. This doesn't swing low enough to have more real answers. But that's okay. I can find the other zeros using the quadratic formula. So x is equal to -b, which will come out to be +4, plus or minus the square root of b squared minus 4ac. C, all over 2 times A. That gives me x is equal to -4 plus or minus the square root. This is 16 minus 20, so -4. I'm going to move that 2 over to them individually so I don't make a mistake. This one becomes -2. And this one, the square root of -4 is 2i. And as my final answer, x is equal to -2 plus or minus I. So the question asks you to find all the zeros. There's the -1, and then there's the -2 plus or minus I. If we were in class, I would ask your group to do the next 5 on your own. I still want you to do them on your own. Nothing would be better for you than to pause this video and try and get all of these graphs on your own. But of course, I am going to do it for you. So letter B, my y-intercept, if I plug an x in, everything is 0 except the 2. So I get 0, 2. I look over at my graphs and I see, where's the 0? E is 0, 2. So I know that this is graph E. And it asks me to find as many of the zeros as I can graphically. So on letter E, I can see that -1 will make 0, and 1 will make 0, and 2 will make 0. So this one's great. I don't have to do all that work that I just did a minute ago. -1, actually, it just asks you to list the zeros. You do not have to write them as ordered pairs. So I can just write x is equal to plus or minus 1 and 2. That one went a lot faster, didn't it? Okay, so it's really only long if the graph has imaginary zeros, because you have to do the synthetic and then do the quadratic formula. All right, letter C. Here's the y-intercept, because if x is 0, everything else would go away. So 0, 4. I look over at my graph. I find 0, 4 is on B. Excellent. Another one where I can see all the zeros. And the zeros are at -2, 1, and 2. So, oops, wrong way. So my zeros are at plus, I can write it as plus or minus 2 and 1. This is fantastic. Letter D. I plug in a 0. I find out that my y-intercept is 0, 6. By the way, I think that this was B. I don't think I wrote that one. Let me just go back and write that. Letter D. So I got to find the one with 0, 6, which is F. Only 1 0. Okay, so at -3, there's going to be a 0, but the other ones are going to be imaginary because that dip didn't make it down. So I'm going to have to use that 3 in my synthetic. So I'm looking at letter F on my graph. I know for you it's all on one page, which is fantastic. And I have -3 as one of the zeros. And to find the other ones, which will be imaginary, I'm going to put a -3 in my synthetic. So I do -3, that gives, and then I put in the 1, the 5, the 8, and the 6. It did go 3, 2, 1, 0, so I don't need to add anything. And then I add, multiply, add, multiply, add, multiply, add. And sure enough, that is the ordered pair. Remember, -3, 0, that's the x, and this is the y. That's the ordered pair that comes from that. So I can factor f of x into x plus 3, remember it's the opposite, times x squared plus 2x plus 2. And I don't have to even attempt to graph this. From the graph, I can see that there is no other real zeros. I know they're going to be imaginary. So I'm going to go straight to the quadratic formula. X is equal to, actually, I wonder if I should complete the square this time, just for old time's sake. So I'm trying to figure out where x squared plus 2x plus 2 is equal to 0. So I can write this as x squared plus 2x is equal to negative 2. I remember cut this in half, square it, and then I write the extra number right here. So the extra number is going to be a 1, and I have to add it to both sides of the equation. That gives me a negative 1 over here. So x plus 1 is equal to plus or minus the square root of negative 1. X is equal to, I'm going to subtract 1 from both sides. And I'm going to go ahead and change that. Plus or minus the square root of negative 1 is just plus or minus I. So my final answer is negative 3 and then negative 1 plus or minus I. I'm kind of a fan of completing the square whenever this is an even number and my leading coefficient is 1, which all of these are 1. So completing the square is, I don't know, pretty nice, but not if you don't get it. So now you have seen quadratic formula and completing the square. You can do the last two however you want. I am going to put the answers here real quick. This is graph A, and the zeros are x is equal to 3 or plus or minus I. And for F, the answers are, this is C, and X, the zeros are 0, 1, and 2. So you have one more that you're going to have to do the long way and one more that you can just do by looking at the graph. So let's go through those two, but on the outside chance you decide to stop and see if you can figure them out. So the way I start this one is I do the Y-intercept. I know this is going to seem silly, but we want to stick with my blue. All right, so Y-intercept is going to be 0, negative 3. I go to my graph. I see 0, negative 3 is graph A, and the only real zero is at 3. So I put my 3 in my synthetic, not the Y-intercept. This is the 1, 0 that we could see. And I do 1, negative 3, 1, negative 3. Add, multiply, add, multiply, add, multiply, add. And that makes sense, right? 3, 0 is a point on my graph. So f of x is equal to x minus 3. I get that from here. And if x were 3, that would make a 0. And x squared, I don't have to write plus 0x, but I do have to make sure I don't accidentally write plus x. This is 0x and then 1. All right, this is a great one. So remember, whenever there's no x term, see this one had an x term and this one had an x term, but if there's no x term, you can use a shortcut. You can literally just say, oh, where is this equal to 0? X squared is equal to negative 1. X is equal to plus or minus the square root of negative 1. So my final answer is there are zeros at 3, and at plus or minus, I'm going to change that to I. So this is great. We got to see all of the different kinds. We got to see finding it just by the graph, using the quadratic formula, completing the square, and now using the shortcut when there's no x term. So it's such a great review. So it's why people think Algebra 2 becomes better. It doesn't become better. It just cycles past its own concepts, and that makes it easier. All right, last one. So this one, if x is equal to 0, then you get 0 cubed minus 3 times 0 plus 2 times 0. So you just get 0. So when that happens, that just means that the y-intercept is 0. So we found that was only true on graph C, and fortunately we could see all three of them. So 0, 1, 2 were the answers for that last one. Okay, so moving on, the Fundamental Theorem of Algebra says that if f of x is a polynomial of degree n, so it's going to change to squared or cubed or quartic, as long as n is greater than 0, this doesn't work if it's a negative number, then the equation f of x is equal to 0 has at least one solution in the set of complex, that means real or imaginary, numbers. And if f of x, this is a corollary, is a polynomial of degree n where n is greater than 0, then the equation f of x has exactly n solutions. All right. In English, in just plain old words, this means since this is cubic, there are going to be 3 solutions. Not necessarily 3 real ones, but definitely 3. Some could be imaginary, some could be real. So how many does it have? This one has, we just said it, has 3. Find them by factoring. So they're telling you to find it by factor. That means this is factorable. So remember, 4 terms is not meant to be scary. With 4 terms, this has got to be x squared and x. And a beautiful thing, you have to put the 3 across from the x squared to make your outers, because you have to make that term. And you have to make this 16 in order to get the 16x. And then sure enough, 16 times 3 makes 48. So these should be your favorite kind, not your scariest kind. Okay, so either x plus 3 is equal to 0, or x squared plus 16 is equal to 0. This doesn't have an x term, so I can use the shortcut of just subtracting and then square rooting, which gives me x is equal to plus or minus 4i. So it does have 2 imaginaries and 1 real. So the solutions are x is equal to -3 plus or minus 4i. So one of the biggest problems that I have with kids is knowing when to look for the zeros, what are solutions, how does this all fit together? So the reason they didn't call them zeros is because I'm solving an equation. If you have f of x is equal to, then you're finding zeros, okay? And zeros, remember, can be real or they can be imaginary. So sometimes the directions will say, find all the real zeros, or find all the actually, it would never say just find the imaginary ones, find the real and imaginary. If they ask you to find the real, instead, they might ask you to find the x-intercepts, which is just another way of saying the real zeros, the ones that actually cross the x-axis. This one, that's if you have f of x, or y is equal to. This one is an equation. There's nothing that says it's a graph. You could make it a graph by calling it y, but instead it's just saying, look, I've got an equation. When is this equation equal to 0? Well, when x is equal to -3 or plus or minus 4i. Those are all the solutions. But if it said how many real solutions does it have, it would only have 1. So I won't ever ask you vocabulary on a quiz or a test, but by default you have to know it, because if I say find all the real zeros and you gave me all of these, or find the real solutions and you gave me all of these, that's going to be wrong. All right, now this one says find all of the zeros of f of x by finding as many as you can on your calculator and the rest by hand using synthetic division. So the last one was very clear. It said find them by factoring. They're saying to you, I know you can factor this. This one is making it clear you're going to have to use your calculator. You can't factor that. So now we're going back to what we did in the beginning of the hour, where you said, all right, I'm going to look at the graph to get as many zeros as I can and use synthetic to get the rest. So let's go ahead and put that onto our graphing calculator. So on your calculator, you're going to want to push the button y is equal to, which is right up here. Just to save you a few minutes of watching this video, I did already type it in. You don't know what the last graph you did was, so instead of just hitting the word graph, I would probably hit zoom and then 6, which is the standard, and it kind of just puts you back into the standard window. So from this, I can see that it looks like it crosses at 2, and it also has a bounce at -1. But to be sure, I'm going to look at the table, which is second graph. And when I do that, I go back up. I kind of scroll up here to the negative. Oh, it's -1. At -1, there's a 0, and at 2, there's a 0. So those are my 2 zeros. And I'm going to use that now to actually do my problem. So again, looking at the graph, there's a bounce at -1, and it passes through 2. So going back to my paper, I write down the ones that I have so far. So the zeros are going to be -1, which you can list it twice if you want, but that would be just to remind yourself that it's a bounce and that you're allowed to use it twice in your synthetic. And 2. It does not matter, this is amazing, it does not matter what order you do these in. So I'm just going to start with the 2. It really doesn't matter. So I'm going to put in a 1, then a 0. Look, there's no x to the 4th. Be careful. +1, -2, -12, and -8. And if we did make a mistake, we'll know it because we should get a 0 here because 2 is a 0. So real quick, add, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. It worked. So I feel confident. So now I can put in, this is really important. You have to do it on the answer to the last one you got. You're going to, it's like when you factor and you factor 16 into 2 times 8, you keep going with one of the factors. Well, 2 is one of the factors. This is the other one. Now I'm going to just work on this one. And you say 4 and 2. And then you just work on this one. We're going to focus now on the -1. So add, multiply, add, multiply, add, multiply, add, multiply, add. And of course it worked. Now what sometimes kids forget is that you can still use -1 again because it's a bounce. Okay, when it's a bounce, it counts as 2 of the zeros. So you're not required to list it twice in the answer, but you might want to just while you're learning. Add, multiply, add, multiply, add, multiply, add. So where does that leave me? That leaves me with x -2 being a factor, x plus 1 being a factor, squared, and then my last factor, remember this is the remainder, so that doesn't count, is going to be x squared plus 0x plus 4, which of course I'm just going to write as x squared plus 4. So one of the biggest problems, I think I said this like 5 minutes ago, that kids have is not following the directions. This didn't say to factor. There are going to be questions on the Chapter 4 test where the directions say factor. This would be the answer. But it doesn't. It says find all the zeros. So what you want to do is you want to figure out when this is equal to 0. You know when this is equal to 0. You know when this is equal to 0. So when is this equal to 0? There's no x term. So whenever there's no x term, I can use this shortcut method of just solving. X is equal to plus or minus. Don't forget your plus or minus. The square root of -4. X is equal to plus or minus 2i. And those are my last 2 answers. So the other reason to write it out would be to make sure that there's 5. 1, 2, 3, 4, 5. But when you're doing your final answer, of course, it is perfectly acceptable, and I'm pretty sure the book does this, to just go ahead and list it like that. Great job. Find all the zeros of x cubed plus 7x squared plus 16x plus 12. So this does have 4 terms, but I can't factor it. When I do x squared and x, I would have to put the 16 here and the 7 here, and that's not going to give me 12. So this must have a unique factoring that didn't work, which is fine. We can go to our calculator and we can find all the zeros there. So again, to save us a minute, I already typed the equation in. So now I'm going to hit graph. And there we go. Ooh, this is a little hard to see. So I want to show you another zoom window that I really like, and that is zoom 4. Zoom 4 is nice because it zooms it in just a little bit, and it also, this is going to sound funny, but it's actually made to the proportions of the window. So if you look at it, it's a 6 in the x direction and 4 in the y direction, where Zoom 6 is a very odd 10 by 10. But remember, our graph is rectangular. I mean, our window is rectangular. So to put a square in a rectangle, that's why these are also close together and these are far apart. So I really love Zoom 4 because it makes the graph more accurate, but sometimes I just need to see more. Going just to 4 and -4 isn't usually enough. That's why I usually choose the standard of going from 10 to 10. But if you're not exactly sure if that's a bounce right there, that's when you can go to your table and I say, okay, it definitely has a 0 at -2. And does it have another one? Let's just go up on this table. And at -3. So I'm going to put those two in and then see what happens. So from my calculator, it looked like there might be a bounce at 2. It kind of went like that. But I can be sure just by plugging those zeros in. So I know that there's 1 at -3. I use the table. I know there's 1 at -2. And we're just going to figure out what the other one is. So let's put in the -3 first. The order doesn't matter. 1, 7. I'm getting these numbers from here. 16 and 12. 1. Add, multiply, add, multiply, add, multiply, add. Now I'm going to put my 2 in. Add, multiply, add, multiply, add. And then now I know that my factors are x plus 3. This one didn't ask for factors, but I'm just trying to review every concept. The other factor is x plus 2. And the last factor is also x plus 2. So when is x plus 2 equal to 0? At x is equal to -2. So indeed, as it looked, that is a bounce. Okay, is there a chance we couldn't see it right and it came right back up at -1.9? Absolutely. So now we're confident. So all the zeros are, you can just say -3 and -2. Next one. So when you see this, if you can't factor it, then your steps are always going to be, number 1, to get as many as you can on the calculator. And then your step 2 is going to be to use synthetic. And then 3, factor or solve. This one we didn't have to factor. It was already down to a linear equation. Factor or solve for the rest. If you're ready to try this one on your own, I will tell you that the answers are -1, 1, and 1 plus or minus I square roots of 3. All right, so if you weren't ready to try this on your own, you know, of course, I'm going to do it for you. So assuming that you can look at these and get those two on your calculator, then let's actually plug those in. So 1, -3, 5, -1, 6, and 4. Remember, if you do forget a 0 in there, you just won't get 0 at the end. It won't work. So add, multiply, add, multiply, add, multiply, add, multiply. That didn't work. 16, -16. See, that didn't work. 1, -3, 5, -1. Oh, there it is. -6. So that's what you got to watch out for. You need it to work. You got to find your mistake. 4, -4, 0. That was an easy fix. Like I said, you would have found this one on your calculator. And then same thing here on your calculator. Add, multiply, add, multiply, add, multiply, add, multiply, add. So now I still have 4 terms, which I can't factor, which means if you didn't really look at your calculator, you don't know which one of these was the bounce. So if you go to your answer book and think, oh, I'm not going to actually type this into my calculator, I'm just going to look at the ones that are given and figure that would have been the ones on my calculator. Your calculator is what shows you whether or not it's a bounce. So you can go ahead and look for that on your own. But of course, I will just show you that it was the one that bounced. So add, multiply, add, multiply, add, multiply, add. So now my zeros, I can list them so far, are negative 1, 1. And to get this 0, I'm going to have to do 0 is equal to x squared minus 2x plus 4. If on the calculator you had the 3 zeros, so we know that it bounced at 1 and at negative 1 it crossed. So if it went like this, you would know whether or not you were looking for an imaginary or for maybe it crossed, not imaginary, but just not a nice number like 1.689. That would also require the quadratic formula. So don't assume that you know what starting with the graph is the best place, because then you have a good idea of whether or not your answer is going to be imaginary or not. All right, so I'm going to do completing the square again. I'm going to bring my negative 4 over to the other side. Oops, that's up minus 2x. Why did I choose that? Just because I think it's really easy when this is even. So I'm going to divide that in half and make it x minus 1 squared. And then I'm going to square that number and tack it on there. So I'm going to tack on a 1 to both sides of the problem. And that gives me negative 3. And then this is super easy from here. I square root both sides. And then I add 1 plus or minus, and I change this to I square roots of 3. I think it's a little easier than the quadratic formula, but that's just me. So 1 plus or minus I square roots of 3. So for this next one, we need to go back to our calculator, and I already typed it in. So we're going to see how many zeros that we can find, but it has a rather unusual graph. So you can see that it doesn't have a bounce at negative 2, but it kind of flattens out at negative 2. That often implies, not a guarantee, but often implies that it does have more than 1 0, but it actually has 3 of them instead of 2. So if there had only been 2, it would have gone back up, but because it has 3, it kind of flattened out before it went down. So we're going to try negative 2 3 times in our synthetic. And of course, the other 0 is 0. So let's go back to our paper. So from our calculator, we learned that 2 of the zeros are negative 2 and 0. So the 0 you actually could have just factored out and seen that one. X times x cubed plus 6x squared plus 12x plus 8. You didn't actually need to find it on your calculator. You could have found it by factoring, but that's okay. And we can actually, believe it or not, still put 0 in synthetic, as weird as it may. It's going to be a little odd when we do it, but it'll still work. The hardest part for people is remembering that there's a 0 here on the end, because remember, it goes 4, 3, 2, 1, and then usually there's a number at the end. So we're going to hold that place with a 0. So add, multiply, add, multiply, add, multiply, and add. And when you do this last one, you'll just get 0. That's the remainder, or the y value, when the x value is 0. So let's go ahead and put in our 2. So when I put in my negative 2, I add, multiply, add, multiply, add, multiply. And as we expected, when x is negative 2, y is 0. But what I was trying to say is because the graph flattened out, so at -2, it came down and it kind of flattened a little bit before it went up right through 0 there. That indicates a multiplicity, specifically an odd multiplicity. If it had been even, it would have bounced. So if it happened 2 times, it would have bounced, but it didn't. So I think that this is going to work again. -2. Add, multiply, and sure enough, it did. And running out of room just a little bit, but we can do it one more time because -2 is a 0 3 times. Add, multiply, add. So this is what a graph will do when you actually did find all the zeros. You didn't need to go down to this last step, which, by the way, last step, x is 0. So actually, no, this is the remainder, just 1. You got all the way to the end. We already did the x is equal to 0. So that's what it'll look like if a 0 repeats not an even number of times to create a bounce, but an odd number of times. So this next section looks complicated when you first look at it, but we actually did this last class. We're doing the exact same thing, except that now we're using imaginary zeros. When we did it last class, we did it with all real zeros. So the complex conjugates theorem says that if f is a polynomial with real coefficients and a plus bi is an imaginary zero of f, then a minus bi is also a 0. So if I told you that 1 plus 2i was a root, then 1 minus 2i is also. Okay, which makes sense. When you're doing quadratic formula, you always get 1 plus or minus, and that I just came from a negative underneath the radical, but it still produces a plus and a minus. So what does that mean for us? It means that since they gave us 4i was a 0, we know that -4i is also a 0. So you might remember from last class that we can write our function either as y or f of x, I'll take either, as x plus 1 minus 1, x subtract that root, and then subtract this root. So minus a minus 4i would be plus 4i. And also, like last class, you are allowed to leave your answer in factored form, but you can't have any i's or radicals. No I and no square roots. Okay, so we are going to do a little bit of multiplying out, but fortunately they're conjugates, which makes it very easy. The first times the first, the inners and the outers cancel, and then the last times the last is -16i squared. But remember that I squared is equal to -1. So this is really -16 times -1, which becomes x squared plus 16. Again, your book is going to multiply that out further, but you don't need to. I'm perfectly content with that answer. Now, it does get harder. This one was easy because it wasn't actually 1 plus 2i. It was just the -4i. It is about to get a little harder. So I'll use f of x this time. I'm just going to switch back and forth between y and f of x to remind you that they're interchangeable. They have different uses, but they have the same meaning. Remember from last time that we do x minus and then x minus. So that gives me x minus the 3 plus I. That's one of the zeros. And then the other one is 3 minus I. So you are going to want to simplify that to x minus 2 times x minus 3 minus I, x minus 3 plus I. Again, a lot of people accidentally make one of these plus and one minus. Make sure you get that correct. And while I don't require you to multiply the whole thing out, you aren't allowed to have I. So I am going to go ahead and at least distribute this. So first I'm going to distribute the x, which would give me x squared minus 3x plus ix. And then I'm going to distribute the -3, which gives me -3x plus 9 minus 3i. And then I'm going to distribute the I, which gives me negative ix plus 3I and minus I squared. So lots of good things happen. My 3i's cancel, my ix's cancel, and this I squared, negative I squared is negative negative 1 becomes positive 1. So altogether this becomes x squared minus 6x, there's two of these, so minus 6x, and then that 9 and that 1 make 10. It's super easy to check if you got it right. Well, not easy, but it can be checked by using the quadratic formula on that, and the answers should come out to be 3 plus or minus I, which I know you don't feel like doing, but just letting you know you can. Okay. I am going to take a minute. If you would like to skip this couple seconds of video here, I am going to show you a shortcut that some kids like, but some kids find very confusing. So from this step, when you had x minus 2, and then x minus 3 plus I, and x minus 3 minus I, the way some people jump to the answer is they say to themselves, well, let me leave this as a unit. And then I know that it's always the first times the first, and then the inners and the outers are going to have these two pieces added together. And if you add 3 plus I to 3 minus I, you get 6. So minus 6x. The minus comes from the fact that they're both negative. And then the last times the last is going to be 3 plus I times 3 minus I, which is 9, inners and outers cancel, minus I squared. So 9 plus 1, which is 10. If that made sense to you, great. That's something I definitely teach in pre-calculus. But on the outside chance you're able to grasp that now, you can go ahead and use that. If not, just multiply it all the way out. It wasn't that terrible. All right, you should really, I always say this, you should really try the next one on your own. But of course, I will do it out. Just erase that. Okay, so f of x is going to be x minus 3 times x minus 1 plus I square roots of 5. And even though they didn't tell you, the third 0 must be 1 minus I square roots of 5. But as far as the roots go, you still do x minus. It's always x minus the 0. You might have just heard me call it root. There are definitely textbooks, especially from my generation, that call it roots. All right. So again, I'm not going to do it the shortcut way. If you understood that, you should try it. But I'm just going to distribute the negative and then multiply out. It's a tough one. So first I'm going to distribute the x, which gives me x squared minus x plus I x square roots of 5. Then I'm going to distribute the negative 1, which gives me negative x plus 1 minus I square roots of 5. And then I'm going to distribute the I square roots of 5, which gives me negative I x square roots of 5 plus I square roots of 5. And then the last times the last here gives me minus I squared square roots of 25, which we'll be able to simplify quite a bit. So luckily some things cancel. These cancel and these cancel. That gives me x squared minus 2x plus 1. And this guy becomes a 5, and the negative I squared becomes plus. So plus 5 for a final answer of x minus 3 times x squared minus 2x plus 6. Okay. Of course, you can multiply, like I said, the book will multiply that out all the way. All right, there are 2 more to practice on. I'm going to go ahead and write the answers because I really would love for you to try these on your own. X squared minus 2x plus 10 is the answer to 4. And the answer to 5 would be x minus 2, x squared plus 4, and x squared minus 8x plus 10. But of course, I am going to do it for you. Okay, so a little review from the other day. The other 2 zeros, if positive square root of 2 is a 0, then negative square root of 2 is a 0. And then from today, if 1 minus 3i is a 0, 1 plus 3i is a 0. So this is going to be a big equation. I'm going to start over on this side. X minus the square root of 2, x plus the square root of 2. X minus, remember this is the place where people go wrong, so you might want to write x minus right away. 1 plus 3i and 1 minus 3i, but they're both x minus. So this gives me x squared, my inners and my outers canceled, and the square root of 2 times the square root of 2 is just 2. This one, I'm going to distribute my negative, and then I'm going to multiply it out. You are welcome to skip steps that you think you're capable of doing, but if you skip steps and then get the wrong answer, I really need you to accept the fact that I will not give you partial credit when I think you've skipped steps that I warn you are difficult. So I would show those steps. Okay, I'm distributing my x squared minus x minus 3ix. Now I'm distributing my 1, which gives my negative 1, which gives me negative x plus 1 minus 3i. And now I'm distributing my negative 3i, which gives me negative 3ix, positive 3i, and negative 9i squared. And hopefully you caught it. I did make a little mistake. This is a plus 3ix. Okay, so the 3ix's cancel, the 3i's cancel, and the 9i squared, that I squared is a negative 1, becomes a plus 9. For a final answer of x squared minus 2 times x squared minus 2x, don't forget that little 1 there, goes with the 9, plus 10. These are long and hard. You guys have really come a long way since the beginning of the year. Next one. So even though they didn't say it, we know that there's actually going to be 2 more zeros because if there's a plus 2i, there must be a minus 2i. And if there's a 4 minus the square root of 6, there must be a 4 plus the square root of 6. So f of x is x minus 2, x minus 2i, x plus 2i. I am grouping them together to make it easier. X minus 4 minus the square root of 6. And here's where people go wrong. X minus 4 plus the square root of 6. All zeros are x minus. That gives me x minus 2. So the inners and the outers cancel, and I get x squared minus 4i squared, which I will be able to simplify to x squared plus 4. And then on the next one, I take the time to distribute the negative before I try and multiply it out. And also notice I keep writing all the steps. That's correct mathematical form there. So first I'm going to distribute the x, which gives me x squared minus 4x minus x square roots of 6. Then I'm going to distribute my negative 4 to give me negative 4x plus 16 plus 4 square roots of 6. Then I'm going to distribute the square root of 6, which gives me plus x square roots of 6 minus 4 square roots of 6 minus the square root of 36, which is just minus 6. And for my final answer, you guys are doing great. Thanks for hanging in there. I get x squared. I must cross off what cancels. So that x squared roots of 6 and the x squared roots of 6, the 4 square roots of 6 and the 4 square roots of 6. But I have two of these. So minus 8x. And it's not just a plus 16, it's a plus 16 minus 6. So it's going to end up being plus 10. Phew. Hard stuff. You guys are doing great. Solving using the calculator. So I am going to read it before I move to the calculator. A tachometer measures the speed in revolutions per minute, or RPMs, at which an engine shaft rotates. Some of you might have a tachometer in your car. It'll, instead of having a normal speedometer, I mean, it'll have that too, but it'll have numbers like 1, 2, 3, but they're actually 1,000, 3,000, 2,000, 3,000. And it's RPMs, it's the revolutions every minute that the car engine is rotating. So we're going to actually be doing a boat. So for a certain boat, the speed x in hundreds of RPMs of the engine shaft and the speed s in miles per hour of the boat are modeled by the equation s of x. What is the tachometer reading when the boat travels 15 miles per hour? So the speed in RPMs is the x, but the s is the miles per hour. So that's how I know that that goes on that side. So 15 is 0.00547x cubed minus 0.225x squared plus 3.62x minus 11. People's hardest part with this one is just reading it. You've learned how to do this math. But the way I know is it says the speed x in RPMs, and then it says what is the tachometer reading RPMs. So you're trying to find the x when you have a speed of 15, so miles per hour. So hopefully you remember how to do this. We're going to set this one to be y1, and we're going to set all of this to be our y2. And the window is the hardest part of that. Obviously, I know you can type that in as y1 and that in as y2, but getting the correct window is everything. So I went ahead and typed it into the calculator to save us a minute here. And then I'm going to hit graph. Well, that wasn't very helpful at all, right? Remember, the key when you're doing a word problem is that it's unlikely a normal window will help you. So you need to be thinking about the concept of domain and range. First of all, I can start at 0. I'm not going to have negative RPMs. So, but it does say in hundreds of RPMs. So they've already accounted for it being in the hundreds. I don't probably need to go up to 100, but let's just start a little higher and say 20, which would really be 2,000 RPMs. I could even go up to 30 since I know that that they do go that high. The scale doesn't matter. It's just going to count by ones. And again, you're not going to have a negative speed, but you do need to make it up to 15. Now, I'm going to make it 20 to make sure I can see the 15, which I did actually forget to graph. And then 15. Okay, so now when I hit graph, let's see if I can see it. There you go. I can see it. And I'm just looking for that point of intersection. If for some reason you hadn't chosen a good window, if you had, still had that one at 10, but you knew you needed to get to the 15, but you didn't know what to do in the other direction, you might be able to see that far out and say, okay, I'm going to make my window a little bit bigger and go to 19, or go to 20, and then 30, and keep going. Was 20 enough? Oh, just barely. So, sometimes you have to play around with it, and that needs to be okay. Okay. Once you see it, you can use your intersect function, which is at calc, so second trace, which is where you get your calc. Intersect is number 5. You can either scroll down or you can just use the 5 button, and it'll do it. It's going to ask you 3 questions. Is this the first of the 2 things you're trying to intersect? And you just hit enter. And it'll say, is this the second? And this is only an important question if you have more than 2 lines. But we only have 2. You'll get there. And it asks you to make a guess. which is also important if you have more than one point of intersection, but we only have one, so we can just hit enter again. And there you go. So just finalizing our answer, we got 19.863247, but remember that that speed is going to be measured in hundreds of revolutions per minute. And I don't want you to say 19.863 hundreds. That's not how people talk. So instead, you would actually move it two places, 1986.324. You don't need the 7 if we're only doing 3 decimal places. But about 1900, almost 2000 revolutions per minute. But the exact answer is 1986 RPMs, revolutions per minute. All right, we only have one more. You hanging in there? A solid monument with the dimensions shown is to be built using 1,000 cubic feet of marble. So this is the dimensions that they want, like the proportions that they want, but they want to keep it to 1,000 cubic feet of marble. So what would X have to be to make that happen? So it's really just a series of little pieces. So I'm going to color code them. Let's do these end blocks here. Remember that in general, the volume of a rectangular prism is length times width times height. So all of these are going to be 3 by 3, but then x tall. So 3 by 3 by x, and there's 4 of them. And then we have these pieces, and there's going to be 4 of them as well. And their base is going to be 2x with a height of x. And also an inner dimension, this dimension though, is going to be 3. So then the area of this base that's underneath the pyramid, I don't know if you can tell, but so we've done all the surrounding pieces, but underneath that is going to be 2x by 2x. And then its height, just like everything else, is going to be x tall. And then finally, we do have the actual pyramid itself. So I wrote it up here. The volume, that's a really bad pyramid. It's hard to draw it that small. The volume of the pyramid is going to be 1/3 base times height. So 1/3, when it's capital like that, that means area of the base versus a lowercase b. When you see area is base times height, that means the length of the base. When you see a capital B, that means the area of the base. And the area of that base is 2x times 2x. And then it has a height of x. They're pointing to that. They tried to show it. And this little piece right there is like a right angle mark to show that the pyramid is straight up and down times x, which is its height. So that gives me 9 times 4 is 36x. And this is 6 times 4 is 24x squared. This is 4x cubed. And then this one is going to be 4/3 x cubed. Now you could combine these, but your calculator doesn't really need you to do that. We're just going to set the whole thing equal to 1,000. If you would like to combine the 2x cubes, of course you can. And you're going to let this one, or whichever one, be y1, one of them be y1, and one of them be y2. It doesn't matter which one you do. And then look for the point of intersection. So how does that affect our window? Remember, you've got to get all the way up to 1,000. So unlike the last one that we were just trying to get 15, it does affect it quite a bit. So I typed the equation in. Notice I didn't even change it to descending order. The calculator really doesn't care. And then as my y2, I used 1,000. So again, the key is the window. I don't have any concept of how big x needs to be. So, you know, it's from 30 last time. I'm going to leave it at 30. But I do know that I need my y to go all the way up to 1,000. But so I can see that 1,000, I'm actually going to go up to 1,200 just to make sure I can see it. I hit graph. There's my one equation. There's my 1,000. So I didn't need to go anywhere near close to 30. Will it help me to switch my window to something more reasonable, like 10? Not really. I'm just looking for the point of intersection. So there's the cubic function, and there's the line. I'm going to hit intersect, which is number 5. I can go pretty quick here, first curve, second curve, because there's only one choice. And the answer is 4.25. Rounding correctly would be 8. So 4.258. That's it. You made it through a very long section. Great job, everybody. I hope you have a great day.